By the way, would you be willing to send me one of those boards?
Absolutely. Give me DM me your address. Hey, it's going.
I think you're good. Yep, I see it now.
Uh
Yep, you're live. I can hear myself.
Oh wait, this chat is actually dead. Does this chat work? Okay, here we go. I can actually see the chat again. Hello guys again. Sorry for the brief disappearance, but we are now up and running. How do I finish the merge? Oh yeah. That's so nice. 50 megahertz? That's 500 megahertz. The reason to set the David Wilmore. The reason that I set the GPIO speed to be fast, no, I don't really have a reason. 10, 50, it's all the same. Although you do pose an interesting point. Maybe it's not all the same. Maybe this is a problem. No, it's all the same. I think this is good enough, though. This is a good time to sample. If we slip in time, that's fine, too. MSO example, the 10 didn't let anything out. What do you mean by the 10 didn't let anything out, but the 50 did? I don't understand what you mean by letting something out. Anyway, while we're going through that, I think we can write a nice comment here. This will be called when we have synchronized our USB. We can put our sync detect code here. Oh, if they're two different types of sync. Our preamble. Okay. So, we actually have a ton of time right now. Like, we basically have from here, boop, till like here to actually like deal with whatever we have to deal with. Oh, interesting. I have no idea why something would not show up at 10 megahertz drive. It's a question by David Wilmore. Okay. Yeah, we do have plenty of time to finish saving off registers. Yeah, and we have no reason not to. So are we using A0, A1, and A5? I think so. Okay, so if each one of these is 2 cycles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We just have to wait a while. Does anybody know how to write a macro in a situation like this so I could say delay for a certain number of... Oh, actually, I could just do that. Hold on. MV or LI T0. Let's see if we can get this to be exactly right. That would be a lot of fun. So I want to wait exactly 32 clock cycles between here and here. So let's see if we can do it. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. On 4 cycles. And then what we're going to try is, I'm going to just say 16 here. 1. Add I T0 T minus 1 C dot add I. E N E Z branch not equal to 0 T0 1B. Does that work? And so this is actually going to execute 1 2 3 4 5. I think this is 5 cycles, right? So C.js is 2 3 61 81. Oh no, it's 3 cycles. I guess branching takes 3 cycles. That's kind of gross. Okay, so 1 2 3 4. So this would be 4 and a NOP. Oh, whatever. Let's just try this and see what happens. Well, no, he didn't get it right. Let's at least take a look at the listing and make sure that this is doing kind of what we think it's doing. Wait, why is this... Oh, do I actually have to explicitly say C? Are you not able to jump backwards into the C branch not equal to 0? That seems moronic. Oh, it's because it's T0, S0, S0, S0. There we go. So now what we should see is this should be roughly the same distance as it was on the other. So this should be around 260. No, 313. 312. 326. So we don't understand something. Maybe. Let us put that around the loop, and then we can measure the length of time that it spends in the loop. So from here to here should be around 280. 322. Maybe something changed. Maybe I just don't remember it right. 283. Yeah, no, so it is about the same. 268. Okay, maybe I just got a bad one there. 277. Yeah, so it is fine. Okay. And then this one looks like it's a bit long. 373. So it is long. Oh, wait, my audio dropped off?
It's working, but it sounds like you're on a different microphone that's further away.
Hello.
Still the same.
Test. Is this better?
Oh, you're better on Discord now?
Oh, on Discord I'm better. Chat was the
Oh wait,
the
no,
mic.
sorry, on stream.
What do you mean?
On YouTube, you're good. On Discord, you're still far away.
Oh, okay. I'll fix it on Discord. Okay, is this better on Discord?
Yes, perfect.
Okay, excellent. All is well again. This is a lot of fun. Thank you for joining me on Discord, Mosseler. This is definitely the way to do it, I think.
Yeah, it's cool.
And like you've already brought some things up to my attention from chat and things like that. So, okay. Let's see how long we are spending saving those registers. (350 nanoseconds). 352 nanoseconds. 352 nanoseconds. Okay. So 352 divided by, or I guess that's what? Times 0.048. So 17 clock cycles? Is that right? 352 nanoseconds. And 48 megahertz is 1 over.
Yep, 17.
Okay, I guess it's yeah, 16.992 is pretty close. So, why is this 17 cycles? So there's 2 cycles because we're doing the load in the store. There's 7 of them. Should we get one more? T2? try SP 40, 48, or 44.
I have a potentially dumb question.
Uh-huh.
That page you looked at earlier on Wikichip for the register list,
Uh-huh.
it specifies that things like A0 are saved by the caller. Is the reason that you have to do it in here because this is an interrupt and that's different? Or is there
Number
another
one,
reason?
yes, it is. That is the main reason you have to save it, because you're an interrupt. But number two, they're just all recommendations. That's just what GCC is going to do.
Okay.
"19 cycles. So some of these, I guess, take 3 and some of them take 2. One, two, three, four, five, six, seven, 8. Or one of them takes 3 and the rest take 2?
Maybe double check what the output is. Maybe it's doing something weird with like some of them compressed, some of them not, or something.
Okay, I'm gonna just spot check this just in case something shady is happening. No, they're all the same. Okay, yeah, let's take a look at the assembly output. They all look like they're compressed. Or is this like... Oh, it's this. You have to do it... I was also doing a load immediate in there and I've forgotten about it. Okay. 374. That looks much more reasonable. Okay, so 374 times 0.048. 18 cycles. 18, is that right? Yes, that is exactly right, because it is 1, 2, 3, 4, 5, 6, 7, 8 saves, which is 16 cycles plus 2, because that's how long it takes for us to go spin the like for us to turn the IO back down. Okay, so that's exactly 16 cycles. Now let's see how long is the whole shebang. 808, 810. Okay, so 80810 times 0.048. 39 cycles. So this is 16 cycles. 17. So minus 17. So that's 22. Oh, minus 2. So 5. So this really is, inner loop is 5 cycles. This is 5 times n plus 1. N51. I'm just going to call this N51 delay. Or N5P1 delay. Because it'll be n times 5 plus 1 cycles of delay. That's a really annoying number to work with, though. N times 5 plus 1. Yeah. Oh yeah, NX5P1. That's a good one. Yeah, yeah. But 5 is really annoying. Why is there not some way to do this with 4 cycles? That would be so much cleaner. Like, subtract 1 and branch if 0 or something, I guess. Is there any wacky... I don't like it. I don't like it at all. David Wilmore, I am doing, it is, I load in the value. Oh, this is n. Then I loop, but my loop is I minus 1 branch if 0. But this takes 4 cycles because it's 1, because it's a c.bnez, and then 3 cycles to actually perform the branch. Yeah, there's just J, B, EQ, Z, and BNEZ. I mean, we could make it 6 cycles, but I don't really like that either. Oh, whatever. That's what we got. That's what we'll deal with. Okay, so 31. Oh, and it's actually not n. So if we want to delay for 32 cycles, minus 1 divided by 5, we put 6 in here and we do a c.nop. And that should be exactly the right amount of time. (10202). Wait. 1 2 So that's exactly not what? What is that? What? 57.6 cycle. What is... That's useless. What in the world? Well, I'm decrementing and branching not equal to 0. That's 16 cycles. I also just realized that's not what I want. I want to delay here. So actually what I want to do is 3. 5 times 3 is 15 plus 1 is 16. Let's see if this works out. $40 cycles. So that didn't work out at all. Two. $34 cycles. So is it not n times 5 plus 1?
I think you typoed. You wrote 740. You meant 704.
Thanks. Why is it times 6 now? Why? Why does this take 6 cycles? That's even an aligned jump to location. No. What happens if we move the knob? No, okay, so it's 8:30 with 3. Okay. Well, I guess branches are even slower than I thought they were. I guess. Oh, gosh, it's slow. Yeah, it's 40 cycles, so it is. Let's at least be exhaustive. You know, there's one thing I'm really happy about, is that compressed instructions at least seem predictable without alignment issues. That's like a really big load off, because that would be, whoo, if we had to deal with that. Oh, I could say cycle. So -1, this would be 21. So it's actually n times 6 plus 5? Oh. You go change the function name, you gotta change it in both places. 6 plus 5 cycles. Okay, yes, so it's n times 6 plus 5. Well, that is what it is, so if we set this to be 1 6 minus 5 is 11. Dang, that's annoying. Why does that have to be off just by that little bit? Whatever. So that's 33 cycles. Well, that's even weirder. That's not right either. Toucans. My goal is for this to be really small. So this has to all live inside of a 1920 byte flash area on the chip. So everything has to fit in 1.9 kilobytes. Oh, actually no. So it's n times, so it's 12 plus 5 is 17 cycles. Is that actually what I have? "33 cycles." Well, that's still wrong, because this takes 2 extra cycles. So it's really... three. So it is still times 6. Is it plus 4? Plus 3? Oh, I think it is plus 3. Does that add up? Oh, duh. Yeah. N times 6 plus 3. 4 small values that it would be. Okay. So...
Wait, didn't we determine earlier that branches take a different amount of time whether they're taken or not taken?
Yes, so if it's not taken, it only takes 1 cycle to execute it. So what this turns into for like the last loop or the 0th loop, you can think about it that way, is 1, 2, 3 cycles. But if it has to loop, you add in another 3 cycles.
I see. Okay.
Okay, so really what this is 6 times 2 plus 3 is 15 plus the extra 2. Everything adds up now. 5 cycles. Note to do. This can be abused. Shift the period, the time. So what we can do is we're going to start this loop at a certain time, but we might actually want to, so like say it triggers here, but we might find out triggering here or here is better. So we can adjust that later inside this code here. Also, I just realized I probably also want to do something else. I'm going to need to have a register ready to go with the address of the cycle counter, because I want to be able to use the cycle counter in order to do fix-ups later. So I'm going to say LA, let's make A4 our cycle counter. And where do we get that? We're going to get that to... So this is 0, 4, 8. So it's going to be this plus 8. Hey Ivan, I'm actually streaming right now online, so it's all public on YouTube. There we go. Cat cam is back on. So what I'm gonna do to systick, and what that's gonna let me do is read times. So if I do need to fix up my times later, like later on, we're gonna have to be able to support it for when users are using DMA. We can then use that to fix up the times. So yeah. How long does that take, I wonder? Uh-oh. Oh, is that not gonna work? Whatever, I'm just gonna hard code that. Or no, I'll put it up here. You know, I really like this whole pattern of like not racing to the end kind of thing. It's a lot of fun to, oh, why did that not work?
Stop and smell the assembly roses once in a while.
Yeah, just kind of go nice and slow. I took out the code, that's why it doesn't work. $726. So that's 34, 35 cycles. So 35 minus 2 minus 15 minus 16 is 2. That makes sense. So that's probably turns into 2 full-size cycles. If they're aligned, it's going to be fast. Okay. Ooh, what happens if we put in a line here? An ALIGN. So let's make all of these specifically C. Apparently we're not allowed to do that. Not sure why we're not allowed to do that, but whatever. Okay, so the answer is really sad things when you use the .align keyword. Yeah, it just inserts 3 full-size knobs. What happens if I say align 1? Just curious. Oh, wait. Does align not work the way I think it does? Yeah, it added none. Oh, this is an extra cycle because... No. Oh, I don't have a good mental model for this now. What is going on? This is a full-size instruction, and it's not aligned. And it's still fast, I guess? Or something? Hello, Gabriel. Literally no idea what's going on there. So I would expect this to be 16 cycles plus I expect this to actually take 3 cycles, so it should be 36 total overall. But it's only 35. Exception maybe. C.LA or just LA on unaligned LA is still only 2 instructions, I guess. Anyway. Seems like as good of a time as any to go sample. It's probably actually like around here is where the sampling is happening, but you're seeing the effect here. So that seems like a pretty good place. Adrian, I am... thank you, Mosler.
No worries.
I guess I'll say it out loud. As I'm tweaking cycle counts for delays, writing some assembly for RISC-V microcontrollers, and eventually do USB. It was just so much easier to read what you wrote instead of think. I'm gonna just assume here is a fine time to sample. And if we want to do anything else in here, we can. We got free time. Actually might be a tad early. It's probably a tad early. Okay, sure, why not? So now what we have to do is look for the end of a sync. So tick, 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 sync. Oh no, sorry. Tick, 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 sync. It's where it's exactly the same 2 in a row. So I guess I'm gonna do that now. Tired counting sheep, wired counting cycles. I don't know. I count cycles when I'm like ready to go to sleep. I actually do pull out data sheets when I'm in bed, ready to go to bed, and I just can't help myself but scroll through them on my little internet. This is big internet. The computer is big internet. My cell phone is little internet. Okay. Yeah, my brain is just poop before, I don't know, 8 p.m. is kind of when it starts to turn on. So what we want to do here is we do want to go read it. So so in our preamble loop, we're going to go read A3. From there, and then we're going to go decide, is this the same as the last time we've read it or different? But it's a little bit weird. So sync done. This happens 3, 4, 5, 6, 7 cycles after that. Oh, so we actually do not want to delay that long in here. Okay. So we actually do want to be A1. So we don't want to... I missed my debug blips, but it will be okay. So what we want is, if they're exactly the same, then we know we're done. But if they're not the same, then we have to keep looking. Okay, so if they're different, we jump out. So here, if we're different, that's good. BEQZ is done preamble. Else we want to stay inside the preamble loop. And so there's going to be 1, 2, 3, 4 because it's not getting taken. 5, 6, 7. Is it 7 or 8 cycles, the J? So that's 4 cycles. So yeah, it is. It's 4 cycles. 1. Oh no, that's right, loads it. So 1, 2, 3, 4, 5. 5 plus 4. House didn't burn down. Sorry, BitLooney. Hey, thanks for the money. I love Scotch. 5 or so. We're doing 32 cycles minus 5 minus 4, so 23 cycles. So 23. This is just awful.
You need something that yells at you when there's a super chat like BitLooney has?
Wait, I gotta figure out more about that. Yeah. I always watch BitLooney's videos, but I very rarely watch any of the live streams, or like any of the live streams. I've definitely never watched, I don't know. I just have a hard time watching other people's live streams. Friday.
They're fun.
So what we want to do is take 32 cycles. We have 23 left. 23 minus 3 is 20. divided by 6 would be 18 plus 2. So c.nop, c.nop, and then we do this by 3. Okay. So that's 1821 cycles. Okay, let's see what happens. Well, I don't know what happened there, but let's just look here. Well, that's not right. We're supposed to exit when we're done the preamble, not in the middle of the preamble. So C branch not equal to 0, A1. A1 is what contains it up there. Oh, we do want to move MV A1 A0. Is that how that works? Dang it. That backwards. Is it A0, A1? I don't think that's it. I think it is A1, A0. That's wrong too. Hello, Rec. Oh wait, where is Friday now? Oh, he's over there. Oh no, oh, there he is. Yeah, okay, it worked. Why is that not working? So the idea is whenever we're sampling, I want to read the value here, and then I want to store it. And then when we're here, I want to see if they're different. And then I want to store it. And we're here, I want to see if they're different. And here I want to see if they're different. But why is it triggering when they are different? It should only be triggering if they're whatever. I mean, I'll try it. Maybe I have this backwards, or maybe I was debugging it and I flipped it and I wasn't thinking. No, that's even worse. Does anybody see the error? I use S0. I'm not using S0 down here. Not blowing away A1. Oh, I am blowing away A1. Last. Because what I'm doing is I'm XORing A1 with... Oh, I could do something clever here. A0, A1. A0. Oh, but I don't. Do I want to do that? There's got to be a fast way to do this. It's annoying that the compressed version doesn't have the ability to output to a different one. So the problem is here, A0 is going to be the value that we came into the loop with. And A1 is just going to be not 0. It's going to be just some number. Yes, we can recover the value. Can we do that? Can we say if we XOR A1 with A0 again, do we get back what we started with? Tricky. I think let's just see if it worked. Here, NJE. Oh. Heck yeah, look at that. We got it in the middle of our preamble. And here we did. And yep. So like what's actually going on here is like it's done, it thinks it's done. Then it gets what it knows to be an interrupt. And then right here is where it lets up. Oh, okay. So this is at 59 stream to be 5922. We are detecting preambles.
Very cool. I've been doing some reading in the docs, and that HPE system that we turned off earlier sounds like it might actually be useful because it will automatically save off RAT0, T1, T2, A0 through A5 for you.
So it is faster, but it is not compatible with GCC's default interrupt behavior. So this is really cursed. I have a closed ticket on it now. Which is oh gosh, this is so cursed. This is what you have to do. And it's actually even worse because in order for this to be portable, what you have to do is call. Like you have to actually use the call command inside your naked interrupt to call the C function from your interrupt, it gets really gnarly, and I don't want other people to have to do that. And so I just want, like, if somebody wants to use that feature, they can, and we'll just also save off the registers as well. And if they don't want to, they don't have to. But I don't think there's anything wrong here. Like we still we're only going to save off these few registers. We have a lot more we're going to save off here, but whatever. Like, this only happens when we actually have a USB message, so.
Okay, fair.
I do have a concern, though. This should be further over. This is really early. Yes, I can, but I don't want to expect... So the purpose of this USB stack is to become sort of like an Arduino. And so I wanted to be able to live inside the boot sector of the flash and be a full USB stack. And then you can use that to flash the rest of the part. It's like a bootloader, so you can run other programs. And I want it so that other programs can still be connected by USB using the code inside of the bootloader. So it matters that whatever mode we're in is supported by C in a reasonable way. So I just don't want to put an expectation on the user one way or the other. This is strange. So 1, 2, 3, 4, 5, 6. So oh, maybe this was right before. I'd say that's pretty close to the center there, pretty close to that one. Let's see if it's in the same place on all of them. So 80 nanoseconds back. .37 nanoseconds back. 34 nanoseconds back. 68. I think that's pretty cool. This looks like it's synchronizing quite well. 84 nanoseconds. Okay, I think this is right. So we are successfully finding the preamble and syncing, and now here is the start of the post preamble. So 1, 2, 3, 4, 5, 6, 7, 8. So we sample here, and the next value is what matters. Alex, I want to be able to give people the option either way. One of the problems with HPE is that it slows down all interrupts. So there are situations where you would want to have it off for interrupts that don't store a lot of things. So for instance, if you're trying to like make a function which is very, very fast response from like a GPIO change or like a really tight DMA loop, then you would want HPE off, because HPE slows down everything else. Like it's like it does a lot of register saving and loading faster than you can in assembly, but it's still doing the saving and loading. And there's a mention on the processor that it's supposed to have a depth of 2 on the new ones, but they're also apparently still also take time. So I don't really know. I have not heard the rumors that there is automatic behavior with it. So my goal is just make it so this will work either way. I just don't want to worry about it. The HP can be on or off, and it's up to the user. Bit process. Okay, so here, what we're gonna do, we've already recovered A1. And actually, we can do something a little bit cleaner. Or no, we can't. No, we can't. So C.XOR A0, A1. So A1 is currently recovered. And we can read A0. Yeah, so we could do all of this all over again. But now, instead of us doing it, whatever we're going to do in a preamble, we can actually use this data. Oh, Friday, stop. Is this right? So yeah, this is really weird looking, but what this does, I think this is right, is it'll read in the bits, so it'll be like high-low, and then it'll XOR it with the last one, which was high-low or low-high. And it goes either high-high or low-low if they're flipped in A0. Go by A1 and it gets it back. And A0 still contains all high or all low. Okay, so that is right. Hello again, DIY in the ghetto. Okay, so in here, we actually want to do the same thing again. This double XOR trick seems to actually do the trick. So branch EQ 0 would say, what does that say? It says that this is a 1, is a 1 bit, and else it's a 0 bit, which actually we can just, oh gosh, though, why is that flipped? That's really annoying. I was going to say, we could just, I guess we could just XOR it a third time, and then we have, I don't understand, Gabriel. You have a bug of when interrupt starts and when it ends? I don't understand that question. I don't want to branch if I can avoid it. I wonder if is there like is equal to 0? What I really want is like invert and shift left or something. I don't know. This is weird. Really don't want to jump. There's got to be a fast way to do this. Add or and XOR sub shift right. Can you do c.add I -1? Does that work? Well, no, because I don't want -1. I just want it to be not that. Okay, so I want to figure out the logic here of how do I take A0, which is going to be like 1, 0, or 1, or 0, 1, and I A0. So yes, that's what that is. And then I can XOR it with the last value. So I get either 0, 0 or 1, 1. And then I can recover A1 for use again, A0 for use in A1 again. So that also like saves it for next time. But then I have this nasty thing, which is either 0, 0 for a 1 or 1, 1 for a 0. And I want to be able to get that to turn into something which is either 0 or 1. Like, how do I use RISC-V assembly and turn 0, 0 into 1 or 1, 1 into 0? Also, we could do branch equal to 0, A1, SE0 complete. XOR with 3 and with 1. That's an interesting thought. So how does that work? So if I take one, 1 XOR 3. Oh, sorry. 3 XOR 3 is 0. 3 XOR, or sorry. Yeah, 3 XOR 1 is 2. I'm not sure what you mean. XOR with 3 and with 1. So 3 XOR 1 is 2.
Like XOR with 3, and then AND as in the AND instruction with 1.
Oh, yeah, I'll do that. That works. Can I do XOR I? Is that a thing?
Doesn't look like there's a compressed one.
Bummer. Is there like a neg? Because we can also do this where we shift. The shift is really tempting because then that gets us to exactly 1 bit. Oh, we could shift and then XOR with 1, but we still have to have 1 register somewhere. Is there any other way of turning a 0 into a 1 and a 1 into a 0? I guess not. Well, darn.
It looks like there is and immediate. There's no XOR immediate though.
Wait, is it C? Oh yeah, C dot and I. Wow.
Oh wait, you're already using it. This is not new information.
If I have to store another value, I will, but I'm just sad. What's complement? Is that neg?
I don't think there is a compressed not instruction.
I mean, I'm willing to use neg is rd0rs. No, that's not what I want. Not is not what I want. I just really want to avoid having to use a constant 3 somewhere. Is there a non-compressed XOR I? There is a non-compressed XOR I. Hold on, I have got to know something. C.AND_I. What is the opcode for that? Could they have done? Oh no, they really are using all the numbers for it. Okay, that's fair. I'm not gonna ding them on that. I would have complained of like, you could have given me like XOR I, but nah, it's fine. So I guess that is. It's just XOR, XOR I, A0 3 C dot and I A0 1. Let's see if XOR I cares if it's aligned. I would really like to know that. So what I'm going to do is up here, I'm going to put in the little debug blip. We're going to make sure that that still works. That does not work. Oh, that's because I have not yet loaded all of that. Okay, here we go. Okay, let's make sure. So this is 40 nanoseconds. That's correct. I'm going to take a XOR I A0 A0 5, for instance. Okay, and that is 60. Okay. And now let's do a C.nop here. Well, crud. It matters that it's aligned.
Wait, does it?
Yes.
It
Oh,
increased by
oh!
1 cycle, and you did a knob.
Oh, snap. Oh, thank you so much for hanging out here. I would have missed that. Oh, man. XOR I and unaligned XOR I both take... And what was that? It was... Yeah, it's like 61 nanoseconds. Oh, okay. Well, that's amazing. That is super cool. Okay. Well, that's mega cool. So that might be a 4-byte instruction, but who cares? Because it's going to take exactly 1 cycle. So 1, 2, 3, 4, 5, 6, because we're not going to take this most of the time. 7, 8. So right now we're at 8 cycles. Okay, and now A0 contains okay, so let's make a summary of our registers. A0 contains the bit. A1 contains the last state. What else are we using? We're using A4 and A5. So A5. A4 contains we probably also want to actually load A4. I don't actually know how to say your name. BRAP Ghanistan? Brapghanistan? I'm really glad to hear that. I really love computer engineering, and I'm so glad that I found it when I was going through college. I learned a whole lot from college on it. So yeah, hit it hard. Right now I'm on Linux Mint. Ghetto and the DIY in the ghetto. So A2 is free, but not for long. A3. Okay, so we're at 8 cycles here. J is 4 cycles, right? Is that right? I can't remember anymore. Darn it. Yeah, so J takes 4 cycles. Okay, so in here right now we have 20 cycles to figure everything out. I think we can do it. We have 20 cycles. I think it'll be okay. I think we're going to be okay. I really hope we're going to be okay. Maybe we'll be okay. This is going to be tight. Okay, so I don't know. I'm surprised that we got this far. I still have another hour left in me, I think. Let's do it. Let's see if we can get some data. Like this is headed somewhere good. So we have our sync, our PID, and our EAP for most packets. Is it MSB first or LSB first? So it says, what is a PID setup? A PID setup is 1101. 1101. Okay. Wait, 1101? Uh-oh. I guess I have to turn on the glitch filter. Okay, so what we got here, let's check, is 110. I don't know, though. Is that right? Okay, let's look up what PID data 0 is. Data 0 is 0011. Is it backwards? 1100. So set would be 1011. Oh, it is. It is backwards. So it goes, I guess, LSB first. Well, there we go. LSB first. So let's store A2 will be our current word. So what we're gonna do is we're gonna do c.slli. I think that is what it is. It is SLLI, right? SLLI. C.slli as a logical left shift zeros are shifted into the lower bits. Yes. A2 1. And we're going to OR C.OR A2 and A0. Okay, so now A2 is going to be shifted up by 1. Good night, SS developer. The second 4 bytes were the inverse? Is that the case? That would make a lot of sense. Also, everything in USB is byte-wise, right? So that would make sense. So it's 1101. Wait, no, sorry. 1011 0100. Yes, that looks like that's the case.
And there's no CRC on that packet, I think. Or, no, sorry, the CRC doesn't cover that, and that's why they do that.
Mike, I hope I can earn your subscription. So, glad that you're here, though. Got it. And yeah, so that makes sense. The second 4 would be inverted. So, okay, so we're still byte-wise. I guess everything here is basically byte-wise, right? Except for the CRC. The CRC is weird. I think. Is there any part of this that isn't a byte?
I don't think so. I think they always work out to bytes, ignoring bit stuffing. Which which I don't know how you want to handle bit stuffing.
Oh, yeah, that's a good point. Bit stuffing is too many ones in a row. So yeah, we have to handle bit stuffing before we do this. S1 is our bit place time. Oh man, yeah, we need to delay 24 cycles here. So we have time to set some other stuff up. Let's just promise we're not going to use that delay function anymore, and then we can reuse those bits. Oh yeah, I see what you're saying. Yeah, we also have to store somewhere S0 for right now. Number of run of 0. Is it 0 bits or 1 bits? I always get that. It's run of ones. Runs of 1. Run of ones. Runs of ones. Wait, the CRC5, how is that byte-wise? Or is the SE0 part of the CRC? I guess that's part of the CRC. Because EOP and CRC make a nice 8-byte.
No, the things in it ends up aligning on the end of a byte, but the things in front of it are odd number. So for example, you have 8 bits of PID, 7 bits of address, 4 bits of endpoint, 5 bits of CRC.
Oh, okay. Thank you.
No worries.
Okay, so if we have an exception where we have to stuff a bit, so it's oh, this is going to be messy. Sammy Tim Gaming. Yeah, I did make a non-Euclidean ray tracer. I was one of a couple people. I think I was the first. I don't really know. Or like, I think I was the first one to do a real-time non-Euclidean ray tracer. Okay, so So we want to add, in the event that A0 is 0, we want to reset S0 to be nothing.
So bit stuffing is a 0 inserted after 6 consecutive ones.
So if we see 6 consecutive ones, then we ignore the next bit. Right?
Sure. I mean, you should check it, but yes.
There's a couple things going on here. I'll worry about that in a minute. For right now, though, what I want to do is down here. What I want to do is I want to say, actually, what I want to do is I want to start it off at 7. 7, 6, 5, 4, 3, 2, 1, 0. Okay, I want to start it off at 8. Branch. Oh man, we are gonna run out of registers so hard. That's right. This is 4 cycles, right? Branch taken is yes, okay. We have 3 cycles in here to do something. I don't know how we are going to do that. Because we have to store, reset the pointer, and advance the pointer where we're writing. Yeah, maybe we should finish the bit stuffer now so we don't forget. I'm trying to figure out how to play with these to really optimize the bit stuffing code right now. I mean, honestly, at this rate, the more I'm thinking about it, we might just end up doing a LUT just to like pile all the logic in there. A LUT would just solve all of this, but if we can do it without a LUT, that would be really cool. Having it all self-contained in assembly. Alex says, just receive the values on D+ directly into the Word. Does that work? No, that doesn't work. You can't do that. Oh, you mean because all the bits line up, you can just XOR it at the end. It's not just that it's super fast, it only saves one operation.
But you're not guaranteed by alignment in the case of bit stuffing, because then you're adding an extra bit.
Oh, yeah, good point. Yes, so yeah, sorry, Alex. I'm not doing that. So 6, 5, 4, 3, 2, 1, 0. We should just go to branch handle bit stuff. Otherwise, if there's no bit stuff, Alex, how does alignment not matter if you have a stuffed bit? Are you saying that you would destuff your bits in post? I'd like to destuff my bits while I'm going if I can, otherwise I have to spend more time later fixing it up. I think we have enough time to do dbit stuffing and to get the data in. Like, if we have time now, we should do it now. Yeah, but you can't detect bit stuffing on whole words. I mean, you can, but it's going to be slow in the same way that doing it right now is slow. But if we have time now to do it, we should do it now because time is free. We just have to be clever about how we construct this. Yeah, I know, Mosler. I know it's easier on an FPGA. Okay, so we can do something a little bit clever here. What I want to do is shift right or shift left and extend our zero and extend our numbers. I need a truly temporary variable. How would I expand these more? Like, is there, if any, is there an any? Somehow an any.
So you mean not equal to 0?
Right, but I want to make it so that the register itself... So what I can do is I can mask this off. So if this is 0, I can AND it with my count, my runs, to reset my count. Oh, I can't do that. I would have to actually set it to 8 if it's 0. Ugh. Okay, so A0 is now 0, 0 for a 1, or 1, 1 for a 0. And if it's a 0, then we want to set it, otherwise we don't. Ooh, if we set it to 7, then we could just say minus minus. So now what we need to do is make it so that if A0 is 1, 1, we turn it into 1, 1, 1. 1, 1 is a thing that I am just not going to worry about for outside of that. Like 1, 1 on the wire. I wish we had like multiply, because then I could multiply 3. Oh no, that wouldn't work. I need to turn 3 to 7. How do I turn 3 into 7? And 0 into 0. I wonder if I...
Or it with the same thing shifted left 1.
Right, but then I need to use a temporary variable, which I don't have right now. Maybe I need to make a temporary register. I think I need to have a temporary register. I'm going to make a temporary register. Okay, now we have plenty of registers again. So A0, or no, A... A4 Does that work? So I have
I think so.
A0 shifted 1, so this becomes 7. Then S0 becomes 7 if it's a 0 bit. Subtract 1. Okay, this looks good now.
Wouldn't line 99 A4 would become 6, right?
Oh, yeah. S0 becomes 7, yes. Okay. So,
okay, I think it's about time for me to go do some no-ops now.
I think that this is all 12 cycles. All right, thank you for coming out, Mossler.
No worries, this has been fun.
I probably have another half an hour left in me. I don't think we're going to actually successfully decode any USB tonight, but I do want to see if it's like the timing is anywhere even remotely reasonable. So that's going to be fun to find out.
All right, good night.
Night. Hey, that worked. Oh, we could also store the word place that we're in that register. Okay, so what I'm going to do here is A2 is our running register. S1 is number of bits left. And A4 S1 7. Okay, so in here, this means it's the word is now ended. So the trick that I'm using is A4 is both how many bits we have and how many bytes we have. But I still don't know how to do that with 3. Oh no, I wonder if unaligned byte access to RAM is not the same speed as everything else. We should check that. To do is, oh, wrong one. Byte access to RAM is unaligned, slow. I guess we could always just do 32 bits at a time. Oh, MOA. 31 bits. Yeah, sure. Let's just do 32-bit aligned stuff. That seems like fun. $12, $13, $14, $15, $16, $17, $18, $19, $20. 20 cycles. Oh, I'll be darned. So we still have like... We still have 8 cycles left. I think it's going to be okay. Good luck, MOA. Or Anemone? Anemoine. Don't really know how to pronounce that name. Oh yeah, this is cursed. I forgot about this. In the USB standard, the definition for how CRC5 works is... I do not know how they let somebody write this in Perl. I just do not understand. I think I wrote it out more clearly on ESP-USB. Yeah, I forgot about that trick. I'm gonna have to do that. This here is my ESP-USB code that I wrote a long time ago. So here what I do is I XOR to shift right by 1. Oh, well, that's annoying that that works out. Anemone, you should just get used to doing, like, just writing and reading to USB hardware. Like, that's just what you should just do. It'll be fine. It'll be totally fine. For right now, though, let's just do some c.nops. And let's just see what happens, because the chances of this working are basically 0. Oh, we have to also handle bit stuffing. So one of the tricks I'm going to do here is I'm just going to say if we want to jump to handle bit stuffing, we can just skip the next bit and go back up there. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14, 15, 16, 17, 18, 19, 20. I think this is where it goes. So that's 1, 2, 3, 4, 5, 6, 7. Oh, that's 7, 8, 9. That's 13. So from here we gotta have 30. So 29, 28, 27, 26, 25, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Nope, one more. Okay. Wow, that's cursed, but sure. Oh, and then the other nice thing is SE zeros last an extra cycle. So yeah, let's give it a shot. No way. Is that still lined up? Wait, it might not be perfect, but it's pretty darn close. Whoa, I was not expecting that. What? That's a little weird because it's the second operation that hits it. I'm not sure why, but this is so close. Whoa. Oh. This is so close. Oh my gosh. Well, I want to know why it's not exactly right. Why is it the second EOP? I'll bet you it's just some logic right in here. Wow. I've never had that much assembly get written and it not crash. It's not perfect. Let's put little debug blips every frame right before it samples. Oh, wait. Oh, no, it's not quite right. Well, let's see. Maybe our debug blips are what's messing it up. Oh, yeah. Actually, our debug blips would mess that up, so it's really more like that. No, it's still not quite right. It is really close, though. We're only like 2 cycles wrong. Oh, well that makes... Yeah, I should commit this. This is really close. Well, this is not... Okay, so actually, I think... I'm not really sure how I'm off by like 2 cycles, but... Or 1 or 2. I'm not really sure exactly how many it is. Oh, I could figure out how many it is. We just have to look for when the thing lines up again. Actually, that's another thought. We can just... Oh, I just had a thought. This doesn't have to line up perfectly. We can abuse the fact it only runs every so many bits. So the 20th one ends up in the dead center. And the 4th one ends up in the dead center. So yeah, we are exactly... Okay, so we're exactly 2 cycles off. This is... That is pretty awesome. I am pretty excited. This is not going to be that hard to roll the rest of the way, I think. I'm a little bit concerned that we don't know why the timing is what it is. Maybe there's something here that's obvious. So load 2, 3, 4, 5, 6, 7, 8, but they're really ugly. I really worry about that. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So no, we're actually 4 cycles off. So we don't really understand this then. So there's something that's 4 cycles to... There are 4 cycles being lost somewhere within this loop here. I don't know where they are. I don't know why. Nope, there's no cache on this part. So it should be right. I am super suspicious of the these 2 commands. So theoretically, this here should only add 40 nanoseconds to this. So it should be 104 if our understanding of how all of this works is correct. And it's 146. Okay. Yeah, it's slow. So something about SLLI or ORI is really slow. One 144, 146. So it's not alignment. Is SLLI slow? $104. Is OR slow? Are they both slow? SLLI. So that's... I guess SLLI is just slow. I mean, this should be 80 nanoseconds. No, it's 60. $40. $82. $82. $82. What? So if these two instructions are executed one after the other, it takes an extra clock cycle. Why? No, none of that's documented. This is Super China part. You don't get documentation for 10 cents. This also takes 3 cycles. What happens if I use a compressed instruction? It's cheaper. Is there... Oh no. Is there... Do we have to do non-compressed instructions intermixed with compressed instructions to get the whole speed? No. We're still slipping by the same amount. Oh wait, what am I doing? Okay. let's see if we're slipping now. Or how much we're slipping. I think it's exactly the same as it was before. Yes, it's exactly the same as it was before. That's weird. That's really weird. One of the reasons I like these 10-cent micros is that they're so cheap. I don't think they are actually putting back doors in them. I'm super curious. What if I do c.nop right here and I change the alignment? Does that break everything? No, it's exactly the same. Well, that's relieving. Test. Tried. I'm not actually that concerned about this. I'd like to be able to decode the CRC in the packet. That would be really cool. Maybe I'll have enough time for it, maybe I won't. Other than that, I think it'll be okay. Yeah, I'm not really sure why it's 2 cycles too slow. But I don't know. I'm pretty happy with this. I think I can go call this quits for today. This is some solid progress. Oh, let me leave a note for myself. For some reason, this loop is 2 cycles longer than I would expect. Man, this makes me happy though. Oh my gosh. Yep, and it's lining up with the EAP, but... Okay, well thank you everyone for coming out. It's been a pretty good run tonight, I think. Thanks for the super chats, and I really appreciate the help that everybody's given me. And yeah. Have a great evening. Oh, wait. Friday. See? Say goodbye to Friday. You're welcome.